Now this set of examples is going to include some variables and numbers together. Now the trick here, as we're trying to simplify these radicals, is basically just to treat them separate. Handle the numbers and handle each variable independently. So let's start off with the square root of 25 x cubed. Now let's start off with the break it up step. Even though you can probably look at this and say, I know the square root of 25 is 5, that's not part of the break it up step. That's part of the take the radical step. In the break it up step, we're breaking this up as perfect squares and whatever's left. Since the square root of 25 is a perfect square, just write it as such. But now we need to break up x cubed. Now x cubed, we need to break it up as a perfect square and whatever's left. So I'm going to break it up as x squared and x. That would get me x cubed, and I've broken it up as x squared and x. Now is the take the radical step. The square root of 25 is 5. The square root of x squared is x. And square root of x just copies down. So now in the clean it up step, this is 5x root x. Now I do want to talk about one other quick example just to point out because variables can get a little bit tricky. So let me just talk about a variable problem real quick. Suppose I had the square root of x to the 11th that I wanted to simplify. And I want to break this up as a perfect square and whatever's left. Now, one of the errors I see people make when doing this is I see people write x to the 9th x squared because 9 is a perfect square. Well, 9 is a perfect square, but x to the 9th is not a perfect square. So this is not what you want to do. If we're talking about a perfect square with x to a power, even powers are perfect squares. So what I'm really looking for is I'm looking for the biggest even power that's less than 11. That would be x to the 10th. And what's left is x to the 1st. And this gets into something we covered last lesson because what is the square root of x to the 10th? It's x to the 5th. And remember, you can think about this with rational exponents because the square root of x to the 10th would be x to the 10 over 2, which is 5. And then the square root of x would just copy down. So when we're doing the break it up step with a radical, we want to think about what it really means to be a perfect square. So for a perfect square, it means my power is divisible by 2. For a perfect cube, it would mean my power is divisible by 3. For a perfect power of 4, it means my power is divisible by 4. So let's look at the next example that we had written out. So here we're up to cube roots. So we want to ignore the x and the y for a second and just look at 54. I want to rewrite 54 as a perfect cube and whatever's left. 27 is a perfect cube, and 27 times 2 would get me 54. Then I want to move on to the x's. I want to break up x to the 6th as a perfect cube and whatever is left. And if you remember what I was just saying, when it comes to x to a power, in order to be a perfect cube, what I'm actually looking for is I'm looking for the power to be divisible by 3. And x to the 6th is already divisible by 3, so I don't really need to break anything up. I'm just going to rewrite it. And when it comes to the y's, for y to the 8th, I again am looking for a power that's divisible by 3. So I'm going to use y to the 6th as a power divisible by 3. And when I say, hey, what's left? I got y squared left because 6 plus 2 gets me up to 8. So I have y to the 8th. All right. So that's the break it up step. Now let's do the take the radical step. There's 3 things I can take the radical of. The cubed root of 27 is 3. The cubed root of x to the sixth is x squared. The cubed root of y to the sixth is y squared. These are all values that no longer have a radical. Now I can carry down the values that still have a radical, that I had cubed root 2 that didn't simplify any further, and I had cubed root of y squared that didn't simplify down any further. And now comes the clean it up step, and now it's actually really important because that's a mess what we have right now. And what we want to do in the clean it up step is we want to take anything that's not a radical and bring it together up front. So we have 3x squared y squared. And then we want to take everything that isn't a radical and put it together. Cubed root of 2 and cubed root of y squared become cubed root 2y squared. And now this is a much prettier answer. That's what we mean by clean it up. Let's look at one more example. We're looking at fourth roots now. In the break it up step for 81, 81 is already a perfect power of 4, so there's nothing to break up there. So let's talk about z to the 11th. For z to the 11th, if we're trying to break this up as a power of 4, then we're really saying I need a number that's less than 11 that's divisible by 4, or in other words, a multiple of 4. So one thing you can do on these is just to count by 4s. 4, 8, 12. Oh, 12's too big. Let me go back a little bit. 8. So that's what we're going to use as z to the 8th. And if I've accounted for 8 of my 11 z's, there's 3 of them left. So now the things I can take the fourth root of 81 is 3. The fourth root of z to the 8th is z squared. And I can't do anything with the z cubed. So this is just 3z squared, fourth root, z cubed.